Afternoon, everyone. Appreciate you all being here. I know it's been a long afternoon. I'll try to make this as much fun as possible. One of the theses that I'm going to talk about this afternoon is that software opportunity is created by hardware discontinuity. And back in the day when I was at NASA Ames, just up the road here, I used to lead autonomy and robotics there. It was very frustrating in a way because everything in the world of technology was getting cheaper except for our satellites. So our cell phones kept getting better, our computers kept getting cheaper, and our satellites still cost $500 million. But about 5-10 years ago, that started changing, and then the change snowballed. And now we're at a phase where I call Moore's Law goes to space, where we'll see an Indian rocket earlier this year launched over 100 satellites at once, many of them from the company called Planet up in San Francisco, that is very close to being able to photograph the entire Earth every day. So overall, we're seeing just this explosion of satellites, and they come everything from very big satellites. This is WorldView 3, which is able to photograph 9 different spectral bands at 30 centimeter resolution, down to the Planet satellites, which they often release from the space station, which is how they got these pictures, which you can literally toss these things around like a frisbee. They're only about 1.5 feet long. But this is only half the story, because if you just had the satellites and you had no way to interpret the imagery, you would basically just be taking images and putting those images onto tape drives, which has actually happened a lot in the past. Even with the older satellites, there's vast volumes of imagery that sits on magnetic tape and no human has ever looked at it. In fact, we did a calculation that with the launch plans of the major satellite companies, we're going to soon be at a place where you would need 8 million people doing nothing all day, every day, but looking at satellite imagery. So that brings in the other hardware discontinuity that we're in the middle of, and that is around deep learning. Now, we wonder sometimes why it is that deep learning suddenly took off. I mean, I've been in AI. I did my PhD in AI about 25 years ago, and we were reviewing papers on neural networks 25 years ago, and the neural networks never really worked. And then all of a sudden, about 5 years ago, they started working. And if you trace back why that is, part of it was improvements in the algorithm, but one of the most important reasons for the sort of recent sudden success of AI is all around this hardware, which is the GPU, which was strangely enough invented so that we could all play first-person shooter video games, but it turns out you can basically, at least at a philosophical level, run them all backwards and use them all to do AI. So we're now able, and at Orbital Insight, we're now able to take imagery of parking lots, count all the cars, ports, count all the ships. We can identify trucks. We can identify water. We can identify fields, farmers' fields. We can find oil tanks. And basically, we're now able to take the entire Earth at once and understand what's going on that Earth. And this basically solves a basic problem in Earth observation, because if you have to look image by image at the human eye, and let's say you see a deforestation event, you see a forest cut down, you have no idea whether or not that's representative of a large trend or whether you just happen to look at a really bad spot. Whereas if you zoom out to the iconic Apollo 8 image of the whole Earth, every pixel in that image is 10,000 square kilometers. So you have no idea in detail about what's going on. So I think the real power of AI here, and the real thing that we're most excited about at Orbital Insight, is the ability to simultaneously see the detail and see the whole Earth, or as we say sometimes, count the trees to see the forest. So the overall, and it's important, going back to the talk from the first speaker, the AI here is a small box. The majority of the software we write is to integrate with the satellite companies, to bring in the images, to manage those images in the cloud, to tile them. Then there's a little bit of computer vision and a little bit of data science. I mean, that's the heart of the whole thing, but in terms of lines of code, it's a small part of what we do in order to be able to really run this at scale. Because we have now counted, for instance, in our retail analysis, we've counted more than 6 billion cars. And in the oil tank analysis that I'll talk about in a minute, we've ingested imagery of the whole world to find all the oil tanks in the world. So I'm going to talk about a few specific examples just so that I can make it a little bit more concrete about what you can do with this technology. But these are just indicative of a much larger set of applications that we're starting to explore. And as I said, it all comes down to the combination of these high numbers of satellites, the high repeats of imagery we can get, plus the GPUs and deep learning that let us analyze those images in the cloud at scale. So one of the most obvious things to do, and this is very popular on Wall Street, is just count cars. I mean, if you want to know whether or not Target's beating Walmart or Home Depot's beating Lowe's, or whether the U.S. economy on the consumer side is getting better or worse, you count the cars in the parking lots. So we noticed, for instance, late last year that Macy's was having a lot of problems with their car counts, and then they started closing their stores. And we also noticed more recently that Chipotle was actually starting to get better. So if you remember a while back, Chipotle had a big problem with E. coli in some of their foods. The stock took a real hit. Well, first their sales took a big hit, then their stock took a big hit. We started seeing a recovery because eventually, people forget and they start going back there and they realize the food's actually pretty good. And there's no more negative news stories. So we started seeing the car counts recover. We put out some press releases on this, and fortunately for us, once we stuck our neck out like that, they actually did do well. They announced a large increase in sales, and their stock went up 5% in one day. So we look like geniuses. We're actually a little bit lucky. It turns out that we're really not right all the time. There are many other factors in total sales than just car counts, but we're way over 50%. The kind of odds we have on these predictions are much better than what you could ever get in Las Vegas. So overall, the application's been very successful as a part of how you get an overall picture of U.S. retail and the U.S. retail economy. You can also back this thing out and look more generally. It doesn't like my animated GIFs. So if this animated GIF were to actually work, it would show 2009 to 2016. Because we actually, since we can run at scale, one of the things we've been doing is taking the major cities in the world and ingesting all of the imagery of those cities. So here we ingested all of the imagery from in this example, all the digital globe satellites for 6 years, and computed the expansion of cars. And we were able to see that they started mostly just being in the downtown areas, and then gradually you see in most cities that we looked at the expansion of that car traffic more and more out into the suburbs and the broader areas. Another example that we've been looking at is around oil. I don't know if most people know this, but it turns out that crude oil, is stored in tanks with floating lids. And the reason they do this is that if there's an air gap between the oil and the lid, all the volatile compounds in the crude oil will escape, because crude oil, as its name would imply, contains everything from sludge to propane. So basically the propane escapes into the air gap, and then as soon as you fill the tank back up, all the propane gets pumped out into the atmosphere, which not only creates pollution, it also is losing part of your product. So instead what they do is they float the lids right on the oil, so there is no air gap between the oil and the lid, which is basically tailor-made for those of us in the satellite industry, because it means that we can look from above and see how full the tank is by looking at the shadows here, and you can see them on the slide here, the shadows cast by the thick sides of the tank against the floating lid. So if you see deep shadows, it means the tank is mostly empty. If you see no shadow at all, it means either it's a really cloudy day or the tank is full. So we actually have to, it's one of the complexities in what we do, we have to actually control for things like clouds, but once we've done that, we can get a very good idea of how full these tanks are. We've shown in the US that we're able to track quite closely with the US government data and understand how much oil there is in these oil tanks. And we started going outside the US because a lot of the data we track is good in the US but less good in the rest of the world. So we started looking at China, and as we started looking at the imagery, we noticed there were all these tanks that weren't in the databases. So there are well-accepted databases used by folks like Bloomberg, folks like Thomson Reuters. Basically, oil is the largest traded commodity in the world, and these are the databases that are used by the oil traders to track oil. And we started to think that maybe they were incomplete because we were seeing lots of tanks that weren't in the databases. And so we actually decided to train a convolutional neural network to find oil tanks. And we had to do this, as we often do, as a human-robotic joint project. So basically, the AI found many examples of things it thought were oil tanks. but still much less than all of China. So it would find, say 2,000 examples of what it thought were oil tanks, and then we would have people go and look at each of those, which you can do, about as fast as you can swipe left or right on a Tinder image. They would actually go through and say oil tank, not oil tank, and so you can quite quickly QA that, and then that becomes training data for the next iteration of the AI algorithm. And over time, we found not only all the oil tanks in China, but we've now found all the oil tanks in the entire world. And so places like China, we found we're significantly underreporting the amount of oil they had in storage. I'm sure it's not for any particular reason. It's just because it's lots of different companies. They've been putting in oil tanks at a tremendous rate, and so we found about 200 million barrels of oil storage in China that was not in anybody's databases. We found a lot in Europe. We found actually somewhat fewer in the Middle East than we thought we would. So overall, we're finally getting to the point where we have a really concrete idea of how much oil there is. And the hope here is that by giving real data to the markets and to the world about oil, we can help maybe dampen out some of the price swings we've seen around crude oil over the last 10 years or so. Another application we've been looking at more on the humanitarian side, and this is joint work with some folks at the World Bank, is looking at poverty mapping. One of the challenges in working at impoverished nations is that the places that you most need to work are the places that have the worst data. So in the US, Europe, other places like that, you have fantastic data. You go to places in the third world, often they don't know where poverty is. And you also don't know when you're working on it whether it's getting better or not. So some of our colleagues at the World Bank had done a recent study in Sri Lanka and had really accurate poverty data on Sri Lanka. So we leveraged that data as test and training data. And we computed agricultural productivity, car density, and building height as 4 different possible correlate metrics for poverty. And then they showed in the academic papers they've been writing how those metrics can be used to predict poverty. And the hope is, we're now studying with them other countries as well. The hope is eventually we can get generalized metrics that can be used in many countries in the world, sort of in between the larger studies that are done of poverty by boots on the ground. As was mentioned in the intro, we've also done a bunch of work on agricultural yield. I mean, we've been able to show that not only can we do places like the US, but we can also do places like Sri Lanka, and pretty much by using the right spectral bands and the right training, get this data for essentially any region in the world and get early indications of food security issues pretty much anywhere in the world at this point. So popping out a little bit to the bigger picture, the long-term vision for this and what we're doing and what some of the others in the field are doing is to leverage AI and to leverage satellites and drones and other sources of geospatial data to really get an objective measurement of what we're doing on the Earth and what we're doing to the Earth. So the ability to track entire supply chains, because with this technology we can see mining activity, we can see storage and movement of iron ore, we can see steel plant activity, we can see car manufacturer, we can see import-export lots, we can see dealers' lots, we can see consumer behavior of purchasing cars, and the same thing for other supply chains as well. So to be able to get the kind of visibility on the physical world that we often take for granted on the internet world, and actually if you put those two together, you have a pretty good idea of what's going on in the world economy from an objective point of view. Whereas today, if you peel back the onion on pretty much any expert report on GDP or any other factors of the world economy, it eventually roots down to some government report that you may or may not believe. So we're trying to replace that rumor and government report with objective measured facts from multiple independent sources. So just to summarize, we think this is a really interesting application of AI. It's made possible by these major advances in hardware, both on the satellite side as well as on the GPU and deep learning side, and ultimately impacts the way enterprises run, the way money is invested, the way money is loaned, the way insurance is done, as well as the way non-governmental organizations like the World Bank or the World Resources Institute operate to protect our environment and help impoverished areas, and also how governments ultimately manage their own countries in the world. So thank you very much for listening.